Okay, so let us do this test here, 6.2C, these questions, okay, class 9 maths. If you go to your textbook, page 113, you'll find that. So let's start with B5. There a diagram is given to us, so let's just draw that first. By looking into the text, hanging here is a triangle and a baseline is there. And here, this is mentioned as PQR. Let's do slowly. And up here is cut segment AB, and below here is cut segment CD. Okay, CD. This angle has been given as 127 degree. This angle has been given, I think, as 50. You have to find this Y and here X, these two angles. So draw that. Let's write down get given here. So given to us is, in the figure here, AB is parallel to CD, comma, angle APQ equal to 50 degree, comma, angle PRD equal to 127 degree. And with this, we have to find out X and Y values. Okay, so let us start that. Let's start with this. AB is parallel to CD as given. The question. So we know that when two lines are parallel, let us say this PQ is the line cutting both these parallel lines. Then the alternate angles here. X angle here on the inside of these parallel lines on right side of transversal. And this 50 here, APQ inside but on the opposite side left of the transversal, they are called alternate angles. And we know that alternate angles are equal when the two lines are parallel. We'll learn this theorem in the beginning of the class, right? So here, that gives you APQ value is already there, 50 degrees. So you can just put this one as 1. So this is done. And we'll find Y, right? I think this is quite easy. So let us write down here in triangle P. This is the easier way, I think. You can do by other methods also. This triangle, if a triangle is such that one side is produced, then this is called the exterior angle, okay? Equal to the far away one, near one here, the inside the triangle, there are 3 angles, 1, 2, and 3. This one near the exterior angle is not considered, but the other 2 which are far away from this outside angle are called exterior angle of a triangle is equal to the remote, means far away interior angle. So we can use that angle PRD, the exterior angle will be equal to the angle, okay, they are using X plus Y, because we know a theorem which says exterior angle of a triangle is equal to the sum of the 2 remote, means very far away, remote interior angles of the triangle. So the exterior angle will be equal to the 2 remote interior angles put together. That's a theorem. So we can write here, that gives you X is plus already there, so X can be written as 50 degree, or you can just go the way you like it. PRD is given already here, 127 degree is equal to X is 50 degree plus Y is the only quantity we don't know now. Since we know that angle PRD is given as 127 degree, and using equation number 1 for the value of X here, C. So once we are done with that, you can write here Y will therefore be 127 degree plus 50 come to the left side, become minus 50 degree. So this will be Y equal to these 2 subtracted, giving you 77 degree. Okay, put this one as equation 2 if you like. Then you can write your final answers. Therefore, X equal to 50 degree, as you get this one by using equation number 1. and y is equal to 77 degree, as you get this way by using equation number 2. I hope that's fine, right? Next, B6. Let's go to B6. Let me read the question for us first. Okay, let's draw the diagram instead first. So the diagram that looks like this. A line is coming right here, slanting. Line is going right here, and here, here. Then there is a line here making 64 degree here, and here another line here like this. If you observe carefully, here segment point is marked F, E, B, A, C, D, Q, and here P. And this is also given as 27 degree, this much. And this they have double marked it, which was not necessary, but they have marked this line also as small m, the whole line, which is not necessary actually, okay? But even if it were to be there like this, it's not wrong, okay? Now let's write down, given to us here, given is in the figure EF parallel to DQ and AB is also parallel to CD. We have to keep that in mind, because that is going to be one key thing here. Angle FEB. FEB is going to be 64 degree, and angle PDC is given as 27 degree. With this, we have to find this triangle, angle PDQ, question mark, let us put to get it easy. I mean to spot it easily as we are solving. And then finally angle DEF, these three angles we have to find out. Let us start, okay? Let us start here with this one. AB is parallel to CD. Let us use that since it is given to us. Here, this line AB parallel to CD, and if you consider this as a transversal, then AED inside on the left of the transversal, angle AED will be equal to here inside up on the left side is angle PDC, because we know when two lines are parallel, the corresponding angles will be equal. These are corresponding, this angle and this angle AED, the first one we're trying to find now. Okay, so that gives you here angle AED will be equal to PDC here 27. So we write here 27 degree. You may put this one as 1 if you like. Okay, so that is done. Now let us go to the next three angles we have to find out. So one by one, let us do it. How do we do the next? See here. This is done now. This is already there, so this three. Okay, so let us try to find this one, DEF. For that, let us first take angle AEB, which is a straight line, so 180 degree, because we know that straight line angle, which is simply called as straight angle, is always equal to 180 degree. This is a straight line, so this angle AEB, which is from here to here, from here to here, right? And that angle is composed of three smaller angles here inside. So you can write that angle AED plus DEF, right? So angle DEF. I hope you're getting. Okay, that's good. Now here BEF. So the FEB. The question is using FEB, but you can use BEF also. It's the same angle. What we mean is these three small angles put together form AEB, the big angle. right? Straight angle. Now it's just a matter of replacing it now. AED just now we found out, so we put there 27 degree plus DEF. We are trying to find that, so we just keep it as it is. So next we're going here, DEF plus FEB is given in the question, I think, as you see here, 64 degree. So we write that 64 degree equal to 180 degree. Let us give the reason, since using equation number 1 and knowing that angle FEB is given in the question itself as 64 degree, therefore we replace here with equation 1, replace AED by 27 degree. That's what we mean. Okay, so here now when we add these two numbers, 27 plus this one, 80, okay, 91 degree you're going to get. So here 27 plus 64 is 91 degree plus angle DEF equal to 180 degree. So the next few steps is just a matter of calculating with carefully, I mean, plus 91 go this side, minus 91, sorry, minus 91. So 180 minus 90, 90, 90 minus 1, 89 degree. So you're getting the next one also. Let us put this one as equation 2. One more, we have to find out one more angle. So here 2. Okay, so here finally PDQ. So how do you get PDQ? Let us see here. PDQ has to involve these two lines which have been given as parallel. So we write here also AF is given parallel to DQ as given in the question. So these two lines are parallel, this one and this one. So if they are parallel, then this PDQ, the one you want to find out, is corresponding angle to, see, up on the right, here below on the right, corresponding. So angle DEF, because when the lines are parallel, the corresponding angles are equal, and we know these are equal because they are corresponding angles and the lines involved are parallel. So this is correct. So then we can write down here angle PDQ equal to DEF. Just now you got 99 degrees, so you can write here, since using equation number 2. So let us put this one as equation number 3. So we can write our final answers. All the 3 angles there that were asked to be found out are now found out. So just a matter of writing it down. Therefore, the first angle PDQ, they asked this, is equal to 89 degree. As you can see that by using equation number 3. The next angle AED, so right here AED is equal to 27 degree. This one we have wrapped it out, but here you know on your note you'll be there using equation number 1. Then finally angle DEF, so right here DEF also 89 degree, since using equation number 2, as you can see here. So that's the second one. I hope that's clear, right? Now let us go to the next B7. Okay, so here let us draw the diagram first. Something like this is given to us, like this, and then another line here. Something like this is given to us. Something of this sort, a diagram of this sort is given to us. So here, like this, and like this. So here, this is marked as, draw along with me, E, F, okay, and then this is marked as A, B, and C here, and here D is marked. So let's write down, given as given in the diagram and the question. Here in the figure, BA is parallel to DE and BC is parallel to EF. This much given to us. You have to prove, or we have to prove rather, angle ABC, this angle ABC, this angle, plus angle DEF, this angle, together they make 180 degrees. That's what we have to prove. Okay, so here let's do a simple construction here that will help us. So produce the same straight line on the same straight line, cutting this AB at G, let us say. So you write that, produce FE, okay, produce FE intersecting, means in a manner where it is intersecting this line AB at G. That is, in other words, we know EF is parallel to BC, already see here. So this whole line is straight, so GF we can write parallel to BC, because GF and EF are part of the same straight line, so it will be parallel. So that's what we got by construction. Now we can start. Now here these two lines are parallel, so we can just start this one and this one. Okay, so this plus this, yeah, this is equal to this. Okay, so let us do this. Now we know proof means the answer for it. I'll do slowly. So here, proof, the answer for this, we want to know that these two are equal. So DE parallel to BA, BA parallel, okay, BA parallel to DE. Let us start with that, since it is given like that in the question. So when two lines are parallel, then we know this angle here, let us say BGF, angle BGF will be equal to angle DEF, because when two lines are parallel, the corresponding angles are equal. See here, these two lines parallel, so this one above, on the same side of the transversal GF, they are corresponding and they are equal because the lines are parallel. So let us keep this one as equation number 1. Then let us write here also GF is parallel to BC, as we constructed this in the construction. The last letter is T, okay, construction. Now these two lines are parallel means angle BGF, or I can write here angle ABC. These two lines are parallel, so cut by this one. Let us imagine that this ABC plus this one BGF are going to be equal to 180 degrees, because we know that when the lines are parallel, sum of the co-interior, the two co-interior angles will be 180 degrees. When two lines are parallel, inside on the right side, inside on the same side, inside, they are called co-interior, and they are sum is equal to 180 when the lines are parallel. So we can just write here angle ABC plus BGC is found to be equal to angle, so we can replace by DEF equal to 180, since using equation number 1. So we have proved it, right? This is what they're asking us to prove, you see. That's how we can do it. Okay, so one more question for this test portion, the last one. Just listen carefully. Okay, here, this question, the diagram is giving something like this. There's a mirror here. This sort of diagram represents mirror. And the line is PQ. So I write here P Q mirror. Another line, another mirror is given below. This mirror is R S. So the reflecting side is this, so a ray has come like this and then gone right down here and gone right up here. So these are the rays. Direction is from here to here and then bounce back, reflected ray, and coming back here. A, B, C and D are mentioned. So let us do this. We'll write down the given to us carefully. We'll just write it down in the figure. Okay, in the figure means this figure, PQ and RS are two mirrors placed parallel to each other. Okay, and incident ray, full stop, and incident ray, that means a light ray, reflection of light. AB strikes the mirror PQ at B, comma, the reflected ray moves along the path BC and strikes the mirror RS, at the point C, and again reflects back, and again reflects back along CD, So this is a description of what is happening in the diagram. So you just have to write it down by looking at the question. Now we have to prove something here. To prove AB is parallel to CD. So this line AB parallel to CD means this here AB parallel and CD here are parallel. So for that we have to do a construction. So let us do a construction here. This point B where the incident ray strike is called point of incidence. From there we draw a normal, let us say BM, perpendicular to first mirror PQ. That is called normal. Okay, so we write here, draw BM perpendicular to the first mirror PQ. The incident ray is direction this, so it's perpendicular to this mirror PQ, comma, intersecting RS at the point M. So this perpendicular, which is perpendicular to PQ, 90 degree to PQ, is touching the other mirror RS at M. That's what we mean. Also, let us draw here. Also draw here, see. Here, CN perpendicular to RS. So perpendicular to RS. Let's spot this one as 1, angle 2, to make it easy for us, angle 3, and here angle 4. Okay, next here. And once you're through the construction, let us start the proof, means the answer. Now let us do this. Now when a ray strikes the mirror, that's called incident ray, and after striking mirror, it always bounce back like this, the arrow, the light ray. That is called reflected ray. When you draw the 90 degree to the point of incidence, that's called normal. The angle between the normal and the incident ray is called angle of incidence, angle I. It's always found to be equal to the angle between the normal and the reflected ray, which is angle 2. So angle of incidence always equal to angle of reflection, okay? And this is, we know by using the second law of reflection of light. So write it down. Okay, 1 equal to 2. So if 1 and 2 are equal, now 1 plus 2 together is angle ABC. So 1 and 2 are equal means angle 1 and angle 2 will be equal to half of the big one, ABC. Because 1 and 2 together make ABC and they are equal means each of them will be half of the big angle, right? So here, this is equation number 1. Similarly, here, a many kind of a reflection is taking place. This reflected ray, when it strikes the second mirror of RS, it can be considered to be, in a sense, the incident ray now. So the angle between incident ray and normal here, 3 is incident angle of incidence. Angle between the ray bounce back reflected ray and normal 4, they will again be equal because by second law of reflection. So we don't need to mention the reasons, we'll put similarly here. Equal to half of the whole angle here is BCD. So we write this one, just put it as 2. Okay, and then here, let's deal with this portion once to prove something. I find this way is easier. So let us put here 5 to make it easy, this angle here, from here to here. Then I'm going to write here angle MBQ plus angle 5 equal to, or we can just start like this so that you can find it easier on it. PQ is given parallel to RS as given by the question. And let us say this part you may or may not mention. I'm just mentioning to make it clear. BM is transversal, let us say. This time we're taking BM as the transversal, means the line cutting both the parallel lines. Then this here, angle MBQ plus angle 5 will be equal to 180 degree, because we know sum of co-interior angles always equal to 180 degree when the lines are parallel, right? So this one here inside, on this side of transversal BM, and 5 inside on the same side are called co-interior, and they are together 180 whenever the lines above them and below them are parallel. We learned this theorem already. So here we write MBQ. MBQ will be 90 degree. Angle 5 we don't know yet, equal to 180. Because by construction we were told that BM is perpendicular to PQ, semicolon if you want, by construction. You see, this one is perpendicular to, this is mentioned in the construction, BM perpendicular. So if it is perpendicular, then that angle MBQ will be perpendicular, means 90 degree. So next here, angle 5 will therefore be 180 degree. No sign means plus go that side, minus 90. So this is 90 degree. Let us keep this one as a question number 3, following number 2. We are going to need it. Now next, continuing with this, let us continue. So as you continue, 5 is found out. I'm going to take here okay, let me just put it like this. Angle, if you like, NCS is also equal to 90 degree, because we know CN is drawn perpendicular to RS, semicolon again, by construction. Go and see CN perpendicular to RS. So if it is perpendicular, then this angle here NCS will be 90 degree. So let's put this one as equal to, okay, so next you can just continue with this angle NCS will be 90 degree, here also 90. So they're equal means you can replace by angle 5, and you can using equation number 3, comma. Now these two angles are what? Which are corresponding angles? Check properly. Which are corresponding angles? See here. When you consider this BM and NC, right? Then this 5 above and this NCS above are corresponding, and we have found out to be equal because both of them are 90 degree. So if corresponding angles are equal, then the lines above and below, which is BM, is parallel to CN. We have established now. Now if these two lines are parallel now it's very easy. These two here now, and let us say this is the transversal. BC is transversal. This time BC is the transversal. Okay, then this line is cutting these two parallel lines BM and CN. BM and CN. Then here inside on the left, below the transversal, and inside above the transversal, 3 and 2 are alternate angles. So we can write here angle 2 equal to angle 3 because they are alternate angles. See here, these lines, something like this one, B, M, and cut by this transversal BC. So BC here, and this one here 3, this one here 2, C. So these two lines parallel, see, CN, BM and CN parallel already, and BC is transversal. Then these two inside, below, inside, above, they are always alternate, right? So the alternate angles will be equal because the lines are parallel. So therefore that will give you 2 here. We can replace by half angle ABC equal to 3 can be replaced by half angle BCD, and we can write here since using equations 1 and 2. Okay, so half and half cancelled. So if you cancel these two halves, then we're going to get angle ABC is equal to angle BCD, which are what? Let us check properly. Which are, see here, ABC, A, B, C, and then B, C, D are nothing but alternate angles when we consider, or when we take, simpler English, okay, so when we take the line BC as the transversal. So if you take this BC as the transversal, then AB, this angle ABC and BCD are alternate angles here. This angle from here to here, and these are alternate angles. One way to find alternate angles is the form Z letter, okay, similar to Z. So if alternate angles are equal, therefore the lines below and above the operating, in this case AB parallel to CD. See here, to prove was AB parallel to CD, and we have proof therefore. So that concludes this test portion. Go and give the test. For this test you have to solve exactly, go through it with a video, go through the class like that, and if you have understood, then without looking you solve the same questions as on the text, okay, and submit the same thing you have solved on your tuition copy. Okay, so I hope you have understood.